Okay, probability, question 8. The probability of Jen winning a swimming race is 1 out of 7. Okay, so that they're literally saying this. State the probability of winning as a decimal percent. Slam dunk, right? So 1 divided by 7. Here you have to be careful though. You're watching this, right? As a decimal, this would be 0.14. And this is where a lot of students got this one wrong. They would just go 14%. Nope. You go times 100, it's 14.29%. See how it's not? You always got to go back to what's on your calculator. So I will do this. 1 divided by 7 gave me 0.14285, right? And that kept going. So that, and then to get this, I just went times 100. So be careful. Easy mark, but you gotta know what you're doing. Keep going. Following spinners divided into 4 colors. Spinner was spun 40 times, and the results are as shown on the table. You almost know, you should know at this point, yeah, it's going to be theoretical versus experimental probability. It's kind of setting it up already. Okay, state the experimental probability of spinning white. So you go with white here, 8 out of 40. Because it happened 8 times and 40 total spins. Just keep it like that. And you note probability, so leave it as a fraction. The theoretical probability of spinning white, it's 1 out of 4. 1 out of 4. 4 options, 1 of them is white. Keep going. Expected value, 3 marks. So you got to be careful. Your probability of baseball team winning is 15%. The entry fee is $200. If they win the tournament, the team will receive a cash prize of $1,000. Calculate the expected value. So my formula that I gave you is probability of winning the first prize times the gain of the first, plus probability of winning a second prize, because it could be the case, game 2. That would keep going for as many prizes as there are to be won. But then I will go minus, at some point you have to go minus probability of losing times the loss. These are all dollar amounts, I should say that. Okay. So here we go. Expected value. Probability of winning is 15%. I'm just going to go 15% times the gain. Yes, you win 1,000, but remember the entry fee is 200. So maybe I'll highlight that. The entry fee is 200, so the 200 will go here. You always have to subtract that to figure out your gain. Okay. Then there is no other way of winning. It's only mentioning a one prize here. So you're going to go minus what goes in there. If there's a 15% chance of winning, then this is 85, correct. So 85. So basically I went, to get this, I went 100 minus 15, like whatever the winnings are different. It could be 15, 10 to win the different prizes. You subtract that, and then you get that one. So the losing is usually found once you've entered all the winning percentages. And the loss is just 200 bucks. Okay. It's almost like you go 0 minus 200. That's why the minus is in front of the whole thing. Okay. So now we got to clean that up. This is 0.15 times 800 minus 0.85, right? Divided by 100 times 200, and now you're in business. You're almost there. Even if you make a mistake up here, if your calculations are still solid afterwards, you could still score marks after. So always ensure that at least what follows your mistake is consistent. 0.85 times 200, it's 170. It's going to be negative. Yeah, 120 minus 170, it's negative 50. So here you got to go minus $50. Okay, so that is my expected value here. They don't ask here, and that's just because you know what it is? It's like how many marks. They can't just have too many marks on the exam. So sometimes they cut things, but expected value is negative. Therefore, you should not join the tournament. It doesn't matter how big or small the number is. Expected value either negative, right? This is what would give away whether or not you get the full marks, whether you're referring to it being positive or negative. Okay, keep going. I know I'm going faster, but Acuna is the manager of an assembly line that makes compact fluorescent light bulbs. Workers on the assembly line randomly choose 250 light bulbs to test and found one defective light bulb. There's something about light bulbs, eh? Like a lot of questions when it comes to this is light bulbs. State the experimental probability. This is very interesting that they do experimental again. However, state the experimental probability in fraction form that the light bulb is defective. So 1 is defective out of 250. That's it. That's all you need to do there. And the word state gave it away that it's going to be easy. State the number of defective light bulbs that are expected on a shipment of 5,000 bulbs. So that's a prediction. So that's 1 over 250 times 5,000. So 1 divided by 250 times 5,000, that's 20. 20, and just make sure you add units, okay? 20 bulbs. Yes, because 1 out of 250 is defective. So if you multiply it, then it's 20 bulbs. If they said how many are not defective, then you would go two ways. You can figure out the defectives and subtract it from 5,000 to get 4,980. Or you go 249 over 250 times 5,000, you would get 4,980. Okay, keep going. Odds. The odds against. So a couple things here. The odds, and then it follows with against. Maybe I'll use a different color, and they bolded it. Against what? Hitting a deer. So I would call this D. The odds against hitting a deer is 49 to 1. So because it says against, D actually goes here, and not hitting it goes up front. Okay, so now we know what the numbers are associated with. State the probability. So you know it's going to be a fraction of hitting a deer this year. The first thing I want you to do when you go from odds to probability is to add the numbers together to get your total. And hitting the deer would be the 1 here in this case. So it's 1 out of 50. That's it. So to go from, in short, to go from odds to probability, if you have A and B like this, you would go A over A plus B, like that. How you have to read carefully though, like you have to know what these numbers mean. It could be that you have to go B over A plus B, right? Either one of these, I would say this, or B over A plus B. Depends on the scenario. It depends on the scenario. Okay? That's it for probability, I think. We're good? Legal finance.